Welcome to today's webinar, Total Productive Maintenance Blitz. Today we're going to cover background information about this webinar and the Total Productive Maintenance Blitz event that it's based off of, how the team selected the project, the training and the review that they did, the initial clean and inspect that was performed, root cause analysis and brainstorming ideas to come up with solutions, actually implementing solutions, the report out results, and then we'll finish up with a wrap-up. A little background information about this. This webinar is based off of a DVD by the AME, the Association of Manufacturing Excellence, and SME, the Society of Manufacturing Engineers, and 5S Supply. The presentation follows Modern Drop Forge as they go through a 4-day TPM Blitz, Kaizen Blitz event. So what is total productive maintenance? It's a manufacturing improvement method that increases production and reduces waste through continuous attention to the condition of machines and processes. It's a critical element for any successful lean enterprise that relies on production equipment or machines. A little bit about Modern Drop Forge. The company has been around since 1914, and they produce all sizes of forgings, and they have presses from 2,500 up to 4,000 tons. They have served many industries, including aerospace, mining, railroad, etc. And they have dedication to lean and ISO standards. And they continue to improve quality, improve consistency, and reduce their costs. Modern has been on its lean journey for a little while now. They started because the customers in the marketplace were requesting it. So they started with things like lean overview and tried to implement their 5S system. As you can imagine, as a forging company, it can be pretty dirty. So 5S was a great start to get the teams involved, get people to understand how lean is going to help them out. From there, they tried other lean tools such as quick changeover and value stream mapping. And this all started the Total Productive Maintenance program. Let's talk a little bit about the impact of a breakdown. If a breakdown of equipment or machine occurs, if we have to think of who can this affect, well, of course, it affects the operator. Typically, the operator might be the first person to notice when a breakdown occurs. And when the breakdown occurs, well, they might do something like they try to fix it themselves, notify their supervisor, or maintenance. If they do not notify maintenance, maybe the supervisor would. So now we have a couple of other groups involved because of a breakdown. Well, lo and behold, if the breakdown takes a little while to get done, the downstream process operators will start to notice, and their supervisors and managers will. And then material handling might have to be involved, and then that might get engineering involved. So other downstream processes may be affected. Inventory control, scheduling, shipping, logistics, sales, purchasing, suppliers, customer service, and then all the way back to the customer itself. So sometimes something as simple as a breakdown can have a big impact on a company. So let's talk a little bit how this event was specifically selected. The team looked at different tools like their value stream map, OEE, overall equipment effectiveness ratings, other projects that they were currently working on, including Kaizen events, and of course the filming considerations for creating the DVD. So as you can see on the screen that there's a value stream map there, and that was one of the things that they looked at, is how do we improve our uptime on their equipment. By doing their OEE analysis, they looked through the different reasons and did a Pareto analysis for what were the largest causes or reasons for the downtime. Now, they had teams already looking on things like downtimes of specific equipment, downtime related to changeover, and different items that needed repair. So in this case, they already had teams working on the top 3 issues. So the next issue to work on was an issue with downtime on the conveyors. So as you can think of that, they not just attacking only the top item, they've already been working on those. So this is a company that's committed to a total productive maintenance effort, and by continually drilling down to reduce any of the downtime related to the equipment. So they selected a manufacturing cell that are connected by conveyors. Now, of course, people say, well, aren't conveyors transportation waste? Yes, they are. Now, conveyance, we understand, is transportation waste and lean, considered one of the 7 deadly wastes or 8 waste, whichever way you consider it. And Modern is fully aware that it's waste, and they understand that having a conveyor is just a form of transportation waste. They're continually looking for ways to help reduce waste, including transportation or conveyance. But in the meantime, this is the way they have to do it. Now you realize in a forging operation, the billets are extremely hot, but they want to try to get them from one operation to the next to improve flow and, of course, maintain safety. So in the meantime, this is an integral part of their production process. Any lost time on a conveyor can stop the cell. So where should we start? Even though Modern has been performing TPM events for years, they still like to have a little bit of training at the beginning of the event. Why should you continue training if people have already gone through this? Well, some people have participated in events before and others haven't. And even for the ones that have gone through the event, it's always good to give a little refresher training. So we spent a little time to do a training update of what TPM is and how we're going to perform the total productive maintenance events. One of the good things to do while you're doing these types of events is capture lessons learned from previous events. These are things that we can reflect on or build upon to make things a little bit better. We'll go over those in a minute. They also looked at their OEE data and the information that they had collected. They looked at the big 6 losses, a common term used for the losses related to OEE, including breakdowns, setup and adjustment time, idling and minor stoppages, speed reduction or not running at rate, quality defects, and startup losses. They also looked at their autonomous maintenance worksheets to get an idea of what things they've already done in the past and ideas for improvement. Here are some of the lessons learned that the team mentioned during the event, things from previous events that they could do better. So they need a better preventive maintenance program. So their program has been implemented, but it's continually evolving. And so the team members are thinking, how can we do a better job at doing our PMs? They need to improve sustaining the efforts. And that's very common for many organizations. So they're trying to think of ways of how can we do this better. Now, some of the other lessons learned is it makes it easier to maintain the equipment. So lessons learned aren't always bad or negative. You can always talk about the positive things that happen. They talked about having a better 5S program than before, and 5S is an integral part of TPM. One of my sayings is if you don't have a good 5S program, your TPM program might fail. And they have better cooperation from all the departments. There are other lessons learned, but this is just a sampling of the things that the team said, of things that they could give advice to another group, or things, areas of improvement, or things that have actually are going well so far. So from there, we did our initial clean and inspect. So we used things like check sheets, maintenance tags, and a log. We looked at drawings, manuals, blueprints, past maintenance information. We took some great before photos, and we got all the cleaning materials together. And of course, for safety reasons, you need to perform a lockout tagout. So here's an example of a checklist that they used just to make sure that they covered all the different types of systems and areas within the equipment or machine. You might come up with something that's similar or use this as a guide. Now this is a generic type of checklist, but it has a way that you can make sure that you're covering everything on the piece of equipment. Obviously for things that do not apply, you can just mark them NA. So what they did is they went through these and looked for opportunities for improvement. So you look at things like air systems, access panels. How many times have we seen covers and access panels that are missing? Or the original design had 20 bolts to hold it on, and now there's only 2. What about ducting or wired guides? Any issues with the electrical systems? Things like loose fasteners, bolts, nuts, anything like that. Filters. Are the filters completely dirty? Have they been cleaned in a while? Flow within the system, and that can also include things like fluid flow systems. What about the gauges? Are they marked? Are they operating correctly? Including the hydraulic systems, if there's level indicators for the level of fluid, lubrication systems, any of the mechanical systems themselves, monitoring systems, piping and tubing around the equipment, of course safety and guards around the equipment, and any valves. So this is just a generic list of things that people can look at and decide, these are things that maybe we will check as we go through our system to make sure that we have a good review of what we've done. Now, one of the best methods to identify these issues is to use maintenance tags. And maintenance tags typically would have something, two parts, where there's a top part to the tag and a bottom part. You write what it is, what the item and problem is, and then you rip off the bottom part so that we can put it into a maintenance log. And so what it does is visually allows people to see we have problems in this area, or this needs to be fixed. Now, important thing to do is make sure that you take these items, get them into a log sheet or record them somehow to make sure that we can track these through until they get done. Now, let me give it a little caveat or a warning. During a TPM event, you don't want the event just to be maintenance catching up on all the preventive maintenance that they haven't done for the last 6 months or 1 year. We really want to focus on improving the equipment also. So this is just a way to make sure that we're exactly identifying things on the equipment that need to be improved. Start to review things like the drawings or the manuals or the blueprints, anything that you have available information for the equipment. Review the drawings for accuracy. Sometimes the drawings are from your own internal resources, so you want to make sure, are these up to date? Are they accurate? Do they really reflect what's currently going on? And then what we do is we allow the team to actually draw on the drawings or mark spots. Usually red ink will be good. You can see in the photograph here where they put a lot of issues that could cause breakdowns. So this allows the team to really start to think, well, this is where I've seen problems here. We have issues over here, and allows them to really start to discuss possible problems and then even some solutions of how to fix these things. And then, of course, to get a little bit more up-to-date on the equipment, you might want to review the manuals and any schematic diagrams that are included. Now, we go out and we do the initial cleaning of the equipment. Some companies want to know, should you do the cleaning before the event or do you do the cleaning during the event? It could be situational. In this case, forging operation can be extremely dirty. So what they decided to do was they went out and power washed the equipment before the event. Interestingly enough, they thought that, well, even though we went to power wash it, everything should be nice and clean. But when we tagged out the equipment, we got up to the equipment and started using the rags and the cleaners, they realized it wasn't as clean as they thought it was. The important part about doing the initial clean and inspection is clean and inspect, those go together, is that it gets a chance for the people on the team to get their hands on the equipment. The more you touch the equipment, the closer you are to the equipment, the more you can start to understand how the equipment works, the systems, how the systems interrelate. And plus, during this portion, you can do an inspection. Check for loose cords, cables, loose fasteners. You can also look for things that might need to be fixed or as part of a maintenance program, or things that we can improve to make the equipment better. So let's talk a little bit about after they went out and they reviewed the equipment, they did their checklist, and they did their initial clean and inspect, they started to look for what are the root causes of our breakdowns. So what the team did here is we used a fishbone diagram, often called a cause and effect diagram or Ishikawa diagram, and we used the common elements of man, machine, materials, method, measurement, or environment. And you can see those are the bones off the fish. So we said, what's the cause of the breakdowns for this equipment? And we have the major issues here, man, machine, material, etc. And then we allowed the team to brainstorm ideas of what might be an issue or why might we have a cause of a breakdown. This is a great way to get the team involved and really start to get a lot of ideas out there of what really might be causing the variation or might be causing the input to the breakdown itself. And what we did is we posted the drawings right next to it so that they can see it and that they could get a good feeling for what might be the causes, what category might this go under. So this is just the initial time for the team to start to identify potential problems or potential issues and start to categorize them. So we reviewed all the information of the observations. We allowed the team members to go through and talk about the different things that they saw. We used the tools like 5 Whys to help them get to the root cause. And then what we did was we broke them down into smaller groups, and each group kind of had an area to work on, and the team could drill down a little bit farther. And remember, with things like a tool like 5 Whys, it's really trying to get to the root cause. Don't stop until you really can figure out what was the actual cause of the condition so we can attack that. Okay. Now, having the teams working together was great because they were able to bounce ideas off one another. I've seen this before, or this used to happen on this machine over here. It's a way to get the team to communicate, start to work together, so they can solve the problem. Typically, a lot of times when there's an issue or problem, there's one person, it might be the supervisor or a maintenance person, and they have to try to solve it by themselves. But by doing it with this method, the team kind of gets to work on it together, and they have input from different people. And then the team did brainstorming ideas for improvement. So we just use a method with the post-it notes where we would like to have them write down one idea per post-it note, an idea for improvement, or an idea that would help us get to the root cause, something that we can change, something that we can improve. And then what we do is we put all these post-it notes up on the wall. We group the like ideas together, and that's called an affinity diagram. And then from there, what we do is we have the team names the group and kind of give a little description to the group. This just makes it easier to identify the different ideas that the team members have come up with. And then from there, we can start to decide, is this actual idea that we'd be able to work on? What's the priority of this idea? One of the other things that we've learned and we've used over the years is to do categorizing the ideas themselves. So we had the teams go up and categorize the ideas into A, B, or C. A's are things that the team can do themselves. They don't need any help, don't need any input from anyone else. We have the right members on the team, great cross-functional teams, so we can get it done ourselves. Items that are labeled B are things that we might need help from another department or group that's not represented on the team. And C items are we need approval from management. So once again, if you have a good cross-functional team, a lot of these issues will disappear. Item D's were just great ideas, you just can't really fully implement them now. We usually capture those and put those on a future action item list. These are great ideas, it's just something that it's not going to be accomplished within either the 4-day Kaizen Blitz event or within the 30-day action item list, but we still want to capture these ideas because they're great ideas. And then what we did to help prioritize these items is we looked for effort and impact. How much effort would it take to do this item? Is it low effort, medium effort, or high effort? And effort can include things like man hours, money, just physical effort itself. And then what is the impact? What's the impact going to be, low, medium, or high? And once again, the team has to decide this, and it's a little bit subjective. And what you try to do is get them to be consistent across the board, that low impact here equals a low impact over there, or a high impact here is the same as a high impact over there. And so this takes a little consensus, and the team's working together. But from there, they can really start to set the priorities of what things they should work on first. So if something's low effort and high impact, obviously that's going to get a top priority, something that the team probably should start to work on and finish that week if possible. If it's a lot of effort and barely any impact at all, try to avoid those things at all. And then what we do is we capture these in an action item plan. So I have a saying here, in order for something to change, something has to change. And that's just my nice way to say that, hey, we need to change something here. You can't keep it the same. We're going to have to come up with different ideas or different solutions. So when you're doing a TPM event, this is kind of a general to-do list. This is something you can think of, well, while we're out there, let's see if we can get these things done. So once again, if you do find any safety issues or any potential problems, take care of those now. So while you're out there, retighten any loose bolts and fasteners or belts or safety guards. Do those types of things first. I have a little saying, we call it kind of like the Godzilla factor. When Godzilla was a little baby Godzilla, it's probably all cute and everything, everyone's like, oh, this is really nice. But if you let that item go without taking care of it, when you can, it grows up to be this big monster that actually causes the breakdown. So during this time, get the team out there, get them to fix the things that they can. You might want to consider doing things like repainting equipment or color coding systems if the time permits. Mark all the lubrication points or any of the preventive maintenance points. Okay, and of course make notes of what type of lubrication is needed. One of the best ways to mark these things is to use color coding. We used arrows, we used dots, just very visual ways so that the operators knew what autonomous maintenance they were supposed to do and where it was on the equipment, and then what preventive maintenance that the maintenance folks might be able to do and where it was. And once again, note or mark any of the adjustment points, including the gauges and different connections. So here's the example of what the team came up with for their solutions. I thought we'd just share some of these. These might not be specifically related to your industry or your company at all, but it's kind of more to think about the thought process that the team went through to try to come up with the solution to the problem that they had. So what we're going to do, we'll review the problem, look at the solution, and what benefits did they derive from it, including financial benefits. So on this item here, this is called a breaker roller, and in the picture it's this item that's in the back here, and what it does is the hot billet comes out of the furnace, and what this does is it vibrates the billet a little bit to break off any scale or contamination that might be on the outside of the billet. Right. Now what happened with this is this breaker roller was moving side to side. It was loose. All right, and then what would cause is the billet would come out. It might cause the billet to jam, go down the wrong path, get hung up, so the rest of the equipment wouldn't be able to run. So after the team discovered that this is a potential problem or issue, they used a keyway to make sure that they held the roller in place. Now, some people go, well, that's just common sense, or that should have been done before. Well, one of the things is when you're an older company, you might have had things implemented, it could be years ago, and things where best practices might not get caught up. So something like a keyway, you would go, well, that's just common sense. But maybe back when this system was put together, that was something that they didn't think about it. All right, so what's the benefits for this one? The billets wouldn't get hung up anymore on that chute. And they estimated that savings to be over $9,000 per year. All right, now here's another issue. The chute that allowed the billets to go straight, which is a diverter, was missing mounting bolts. Right? And they weren't aligned correctly. And this caused the billet to jam against the plate. And once again, once it jams, so this is a part here, it could jam over here, and this is a diverter plate here. And if it gets jammed, once again, the billets aren't flowing. The operators are wondering why they're not getting materials to actually make parts. And then they have to go find out where the jam occurred, shut down the equipment, open up the safety cages, go in, clear the jam, start back up, which takes time because you have to get the billets heated back up to temperature to get the system running again. All right. So one of the things is they created a new design on it where the adjustment plates were just fixed on one end, so they only had to make one adjustment. And one of the things we really challenged the team this time is how to do things without any tools, So in this case, they decided what they can do is they could just mount T-handles instead of the tools. And so with the T-handles, I don't need to go run to my toolbox. I don't need to have a tool mounted anywhere near there. It's just a T-handle, a T-bar that I can loosen, adjust correctly, and put back in place. So what are the benefits for this one? It's faster and easier to set up and no more jams. And once again, the company estimated that this saved them about $9,000 or more per year. A pusher rod. A pusher rod would just push the item along, and what they found out is the pusher rod is located right underneath here, that it was actually leaking air and it was actually bent. And what this could cause is many things. One, it could cause it to miss the billet to push it into the machine correctly. Also causing premature wear. It could cause the billet to be pushed in the wrong direction or miss the equipment, once again causing a jam. For this one, the best solution that they had was to emplace the entire unit. What they found out is that the pusher rods in this instance actually got loose. So they did a different method of attaching through the bolts and the alignment of the pusher rod to make sure that it was secure to the equipment and wouldn't move anywhere. And they estimated that this would save the company over $2,000 per year. There's a rejection diverter, and this is a piece of equipment that when builds first start up, if they're not up to temperature or they didn't reach the correct temperature, it wants to make sure that it kicks it out. You don't want a billet that's not at the right temperature going through the rest of the process. And for these plates here, they could be mounted incorrectly, upside down or wrong, where it comes to the point where the diverter actually would entirely miss the billet. Even though it sensed that the billet was a reject, it would activate to kick the billet out. It would completely miss it because the actual plate was mounted incorrectly upside down and missing the diverter completely, or missing the billet completely. What they did here is they realized, well, we got to set up an airproof system, a Poka-yoke type of system, so this would never happen. Now, they do have to do different setups on this piece of equipment, so they do need the way to make sure that when it needs to be set up for the diverter, that it's in place, and if the diverter is not being used, to return it to the original condition. So what they came up with this is they offset the holes, so the diverter plates will only fit on a specific way, and then once again, they use T-handles instead of any tools or anything like that to be able to mount these onto place. So not only did it ensure that they had the plate in the right position, it was also easier to train new people and easier to actually get the job done. This little change in the system, they estimated it would save the company $450 per year. The motor. There's an electric drive motor over one of the conveyors, and the way the conveyor was built, it was right over a hopper with the hot billets in it, and the heat would rise directly up to the motor. And when we went out there, we actually found that the fan unit on the motor was completely missing. Of course, I had to ask, well, how'd that happen? They're like, well, you know, maybe the forklift hit it or something like that. So we had to take a couple things into consideration. So what they did is they actually replaced the entire motor unit with the new motor. They also built a heat shield to go around the motor. And one step further, and it's a good TPM practice, is they put temperature monitors on the motor itself. So there's a little temperature gauge there. This little red one will say hot when it reaches a certain temperature. So that way you can tell if the motor is going to overheat. So things like this made it easier to maintain the equipment, it reduces stress on the motor, and also keep the motor from breaking down at the most critical time. Now, this is one of the exit chutes, and this was an important piece of equipment. And the original design is the billet would come down to the end of the chute and then get picked up and moved to the next piece of equipment. But this is where a lot of problems could occur. If it wasn't seated correctly, or if it wasn't picked in the right position, it could cause a jam. And that jam would actually cause the cell to shut down. Then they would have to call maintenance. The maintenance would come out, and they would have to enter, turn off all the equipment, enter the safety zone through the cage, reset the equipment, and then get it back up and running again. And this was one of the major issues that the team had to work on in order to improve the uptime of the cell. So as the team tried to do a lot of different things, and then we're looking at a lot of different ways to improve how do we prevent this from occurring. So they actually ended up redesigning that entire chute. The pick place for the part was selected to be another area, which caused them to actually have to kind of create a whole new design for it. And they actually did things like slowed the belt down and increased the angle so it would have a better sitting position. So it's funny when you think about it, is that would actually slow the equipment down to actually reduce any jams or any breakdowns. And this was a critical point for the team, because this would probably save the company over $19,000 per year. Now, just one of the other ideas, and there were several, this is another idea, is they had an issue with these air nozzles that are mounted on the equipment that would help blow off the scale. The air nozzles were bent and damaged. Sometimes if a piece of equipment got knocked into them, they would bend them into the wrong position, and they weren't really doing the job the way they were supposed to. So now that the team actually got to look at it and look at what was some of the root causes of these things not performing the way they should, they redesigned them. They actually made them shorter. They went and fabricated them and remounted them on the equipment. So once again, this created better operation, less chance for damage, less chance for them not to be operating the way that they should. Now, one of the other things we noticed is a lot of the lube points on the equipment were not identified. Sometimes people would miss where they were supposed to do their clean and inspect or lubrication, what points they have there for their autonomous maintenance, meaning the operator did some of the basic maintenance themselves, and how do you know that it's running at the right condition. So what we did was we poured over all the equipment, identified all the different lube points. We also looked for the gauges to make sure that we identified the gauges, and then also use things like marking the gauges so you know when it's in a critical condition. In this case, if the needle was in red, we knew that the situation was high or too much. You don't have to train anyone to know specifically what the setting has to be now. Anyone could walk by this piece of equipment and know, hey, if that needle's in the red range, that's too high. So we did this with other things like the fluids and other items on the equipment. Anywhere there were sight gauges and things like that, we went ahead and labeled them to make sure everyone knew what the correct range was supposed to be. Now, this is something you might not think of being a big deal or not, but creating a one-point lesson. This is just the controller for the safety cage that's around the equipment. What we found out is some of the operators and different maintenance people didn't know exactly how to use this correctly. And if they actually tried to push the buttons too fast or not in the correct sequence, it would actually cause it would take longer for it to reset. And they realized they lost a lot of time, believe it or not. They lost a lot of time during the day if anyone did this and they did it incorrectly. So we did a real high-tech solution. We actually just kidding. We did a nice lean solution where we just made a one-point lesson. We showed them what's the correct operation, how to enter and how to reset the buttons. We posted it right on the piece of equipment. Easy to train up new people. If someone hasn't been there in a while, let's say a maintenance person that hasn't worked on this equipment in a while, could just read this really quickly and understand very easily and how to do this correctly. The amount of lost time because people not doing this correctly equated to over $19,000 per year. So by putting up something as simple as a one-point lesson to make sure people are reminded how to do things correctly would save the company a lot of money. So at the end of the event, the 4-day event, the team did an actual report out. All right, so what they do is they get management together, other interested party, other Kaizen teams together, other people from maintenance, engineering, etc. Any group that was kind of affected by this manufacturing cell or that might have any type of interest of what's going on in that cell for production purposes were invited to this the report out meeting. So the team went through and talked about the before state, the way it was, the things that they found, how they went through their clean and inspect. And then they talked about the improvements that they made and the new after state. So the final tally, the team came up with 61 different improvement ideas during the 4 days, which 56 of those were completed during the event itself or within the next 30 days, our 30-day action item list. And the total annual savings for the company was over $50,000. So at this time, I'd like to just kind of do a quick wrap-up, and we'll open it up for questions and answers. And like I said, what you can do is you can go through and you can just type your questions in, and what we'll do is we'll read them off and we'll try to answer the questions. If we didn't get to your question today, feel free to submit them to info@5ssupply.com. And while you're typing the questions, just to give you a couple other resources, other resources that are available. This TPM Blitz DVD is available at 5ssupply.com. Matter of fact, we'll give you a special offer at the end of the event here. One of the books that I personally like is Implementing TPM, the North American Experience. 5S Supply also has things like maintenance stations, maintenance tags, and as you saw in the video itself, or the presentation itself, you saw one of our products called Gauge Range. We have other additional resources, including our blog, our Facebook page, Twitter, LinkedIn, etc., and feel free to visit those. Now here's the special offer. What we'll do is, because this is a brand new video and we got to be part of creating the video for the world premiere price, reducing the price to $129. Right now, this is a special offer that will leave this on sale for people that attended this webinar. Just use the coupon code WBS023 when you check out, and this will be valid through the end of September. So feel free to pick up the video, and you'll also get a sample of our gauge range product that goes along with it. And that's a little bit about my background, and what I'll do is I'm going to get the questions ready here for us to go through. And we'll start the questions now. Okay, let me go through these here. Okay, one of the questions is a number of gauges, oil ports, grease fittings seem to be behind covers or not guards. They have to be removed before maintenance or an operator can get to them. How do you determine the difference between a cover and a guard? Do you know what the other companies are doing when they run into this? One of the things that when we do identify these things and they need to be like an autonomous maintenance or a daily type of inspection, a couple of ways you can do this is one, if it's a safety guard, can we change the type of guarding itself? So an example was in this particular instance there was a chain guard and it covered the chain completely, and what the team did is they came up with the idea to actually use a screen instead over the chain. That way they could look into it, they can see it. They even made holes to be able to get into the zerk fittings or the grease fittings, and they painted it yellow. So it was very easy to see and understand that this is a safety issue. This is one of the things that you have to consider when you're doing total productive maintenance. One of the sayings from Toyota is when they get a brand new piece of equipment in, they look at that equipment and say, that's the worst shape it's ever going to be in. Meaning, we're going to improve the equipment. So when the equipment manufacturers aren't taking things into consideration of like you can't actually access that grease point, we'll take it into our own hands to actually try to redesign it or move the access points so we can get to what we need. One of the common methods for this especially is if you have a lot of grease fittings on a piece of equipment is to create a grease manifold and run the lines out to the individual zerk fittings or where they originally were. This saves a lot of time and also saves any errors from people not greasing what they're supposed to. The manifold makes it convenient because the person can go to one spot and take care of the greasing there. Okay, do you know what OSHA's stand is on modifying covers and not guards? Once again, that's a great question. I think we'll have to find out on a specific case. But what is you can understand that there's a difference between just what is a cover, like a maintenance type of cover, but what is a guard? What's considered a guard? In that case, we'll probably have to look it up to find specifically what would meet your needs or what that specific situation is. If you feel like it, you can send that one to info@5ssupply.com. Okay, here's a question. 5S and TPM are the same. Would you say that's correct? Actually, 5S and TPM are extremely closely related. But the way I kind of consider it is 5S to me is something that any company should start out as if they're first starting on their lean journey. That's one of the things they should really focus on. A lot of companies struggle with 5S and trying to do it correctly. But 5S will build in a lot of the things that we need to be able to have a good total productive maintenance program. So if a company, you can start out with total productive maintenance, but you would obviously be doing 5S with it at the same time. So 5S and TPM, I would not probably consider them the same, but I would consider them very close cousins or very directly related. As I mentioned before, if you don't have a good 5S program or a 5S system, your TPM program will probably fail. And there's a lot of reasons for this. One is 5S really is a discipline, not a mean or evil discipline, just a discipline to can I put things back when I'm done with them? Do I do my clean and inspect when I'm supposed to? And that's a part of SHINE, the third S. And so that'll drive the right behaviors for teamwork and discipline so we can try more complicated things like autonomous maintenance or improving our preventive maintenance program. So TPM and 5S are directly related. but companies can realize that we can have our 5S program without TPM, or TPM without 5S probably wouldn't work, but if you're equipment heavy, you probably need to have both for sure. All right, do you have any suggestions for labeling within a food production area? Sanitation chemicals wear them down. I'm sure they do, especially because of the number of times that you have to do your wash downs there. Some of the things are some of the products that we look for are more have a more robust or a longer wear rating. And also we can do things like actually put covers over some of the signage that we use, including things like a clear vinyl or a clear tape. That'll help reduce the amount of chemicals that are actually attacking on the signage. If it's really bad, there might have to be going into things like engravings, etc. But there's a lot of different ways to attack this, but you want to be able to make it so that typically we're looking for low-cost solutions or things that we can replace easily. So those are the types of things that we would look for, especially in the food service type of industry. And leave it open if there's any other questions at this time. And once again, if we didn't get to your question today, you can send it to info@5ssupply.com, and we'll get back to you as quickly as we can. Your opinion is very important to us, so what we're going to do is we can make this presentation available to you. We can give you the slide version of it. We are recording it, so you'll be able to replay it on our website again. But what we would like to do is send you a quick survey, and it's only 7 questions long. If you do fill it out, we'd be glad to send along the presentation for you. If there's no more questions at this time, I'd like to thank everyone for attending our session today on Total Productive Maintenance Blitz, and you may sign off now. Thank you very much.